Introduction. In this chapter, we will study about polynomials. A polynomial is a mathematical expression consisting of a sum of terms, each term including a variable or variables raised to a power and multiplied by real numbers. Polynomial in one variable is the simplest polynomial. In this chapter, we will study the following concepts: review of polynomials, geometrical meaning of zeros of polynomials, relationship between zeros and coefficients of a polynomial, division algorithm for polynomial. Review of polynomials. Before studying about polynomials, we would recall some basic concepts of polynomials. Zero of a polynomial. A real number u is called a zero of polynomial px if p of u equals 0. Some examples have been given below to understand the above concept. Polynomial in one variable. A polynomial px in one variable x is an algebraic expression on the form given in equation star. Degree of a linear polynomial is 1. Degree of quadratic polynomial is 2. Degree of cubic polynomial is 3. By the geometrical meaning of a polynomial, say px, we mean that we can know the zeros of the polynomial px by just observing the graph of px. We can divide this concept in two cases. First is zeros of linear polynomials and second is zeros of quadratic polynomials.
Graph of linear polynomial. We want to find the graph of the given linear polynomial px equals to 3x minus 12. Let me denote the polynomial px by y so that y equals 3x minus 12. We can easily find the values of x and y that satisfy this equation. Let us tabulate some of the values of y corresponding to the different values of x. These are 0, minus 12, 1, minus 9, 2, minus 6. To plot these points, we first draw the xy axis. Now, these are the points that satisfy the given equation. Using ruler, draw a line passing through these 2 points. This line represents the given linear polynomial. As we can see, the line intersects x-axis at exactly one point, that is 4, 0. And we can say x is a zero of the polynomial. In general, if the linear polynomial is px equals ax plus b, where a is non-zero, then the zero of the polynomial occurs only for one point, that is minus b by a, comma 0. And in case a equals 0, the line never intersects the x-axis and the polynomial is called constant polynomial. It has no zeros.
Here we will understand the geometrical meaning of zero of a linear polynomial. Consider a linear polynomial 2x plus 1. We draw the graph of y equal to 2x plus 1. The table showing the values of y corresponding to the values of x has been given below. First we plot the point 1, 3. Similarly, we can plot the point 0, 1 and minus 1, minus 1. Now we join the points and we see that the graph of y equals to 2x plus 1 represents a straight line, which cuts the x-axis at a point minus 1 by 2, comma 0. Also, the 0 of 2x plus 1 is minus 1 by 2, which is the x-coordinate of the point minus 1 by 2, comma 0.
Graph of quadratic polynomial. Let us consider the equation qx equals x square plus 2x minus 3. Let us denote this polynomial by y. Let us tabulate some of the values of y corresponding to different values of x. Note that for quadratic polynomial, we need more values to plot the graph. Let me plot these points on the graph. We draw a line passing through these points. As it is quadratic polynomial, here we do not draw straight lines to connect the points. As the coefficient of x square is positive, the parabola opens upwards. Now, consider the polynomial px. This is actually the negative of the polynomial qx. These are some values of x and y satisfying the polynomial. As we plot them on the graph paper, we notice that it is just the inverted form of the graph for qx. This shows that changing sign of the polynomial invert its shape. Finally, consider the polynomial x square minus 2x plus 3. We can rewrite it like this. This is the translated form of the second polynomial, with shift of x coordinate through 2 units and the y coordinate through 6 units. We determine some points satisfying this equation and plot the graph. The graph shows that if we add or subtract a constant to a variable, its position shifts on the graph by same amount.
Here we will understand the geometrical meaning of zeros of a quadratic polynomial. Consider a quadratic polynomial x square minus x minus 6. We draw a graph of y equal to x square minus x minus 6. The table showing the values of y corresponding to the values of x has been given below. First we plot the point 1 minus 6. Similarly, we plot points 0 minus 6, minus 1 minus 4, 2 minus 4, minus 2 0 and 3 0. On joining the points, we see that the graph of y equal to x square minus x minus 6 represents an open upward union called parabola, which cuts the x-axis at points minus 2, 0 and 3, 0. Also, the zeros of x square minus x minus 6 are minus 2 and 3, which are the x-coordinates of the points minus 2, 0 and 3, 0. In general, for quadratic polynomial, graph of which represents parabola, 3 cases arise. Here, the graph cuts the x-axis at 2 points b and b'. The x-coordinate of b and b' are the zeros of the quadratic polynomial ax square plus bx plus c. Here the graph cuts the x-axis at exactly 1 point, that is, at 2 coincidental points. So, the 2 points b and b' of case 1 coincides here to become 1 point b. The x-coordinate of b is the only zero of the quadratic polynomial ax square plus bx plus c in this case. Here the graph is either completely above the x-axis or completely below the x-axis. So, it does not cut the x-axis at any point. Hence, the quadratic polynomial ax square plus bx plus c has no zero in this case.
Graph reading. We are dealing with this graphical curve. We want to know the polynomial that represents this curve. Let us denote the function for this curve by px. Notice that the curve intersects x-axis at the points x equal to minus 1 and x equal to 2. That means x plus 1 and x minus 2 are factors of the polynomial px. So the polynomial px, or say y, must be of the form k times x plus 1 times x minus 2, where k is some constant. Now, looking at the graph again, note that point 3, 8 lies on it. So, it must satisfy the polynomial px. That gives 8 equals k times 3 plus 1 times 3 minus 2. This on simplification gives k equals 2. That means px equals 2 times x plus 1 times x minus 2. On expansion, we get px equals 2x square minus 2x minus 4 is the required polynomial. As you may notice, if in the curve of a quadratic polynomial, you can determine the coordinates of at least 3 points on it, then we can easily determine its quadratic equation.
Here we will discuss the relationship between zeros and coefficients of polynomials. This concept can be divided in three cases. Linear polynomial. General form of a linear polynomial is ax plus b, which has exactly one zero, and 0 of ax plus b is given by minus constant term upon coefficient of x, that is minus b upon a. Now we will understand this with the help of an example. Find the zero of linear polynomial 5x plus 4 and verify the relationship between 0 and coefficients. 0 of 5x plus 4 is given by 5x plus 4 equal to 0, implies 5x equal to minus 4, implies x is equal to minus 4 upon 5, that is minus constant term upon coefficient of x. Quadratic polynomial. General form of a quadratic polynomial is ax square plus bx plus c, which has exactly two zeros, say alpha and beta. Then alpha plus beta is equal to minus coefficient of x upon coefficient of x square, that is minus b upon a. And alpha into beta is equal to constant term upon coefficient of x square, that is c upon a. Now we will understand this with the help of an example. In this example, first we will find the zeros of the quadratic polynomial x square plus 7x plus 10. We see that zeros are minus 2 and minus 5, and clearly the relationship between zeros and coefficients holds. Cubic polynomial. General form of a cubic polynomial is ax cube plus bx square plus cx plus d, which has exactly three zeros, say alpha, beta and gamma. Then alpha plus beta plus gamma is equal to minus coefficient of x square upon coefficient of x cube, that is minus b upon a. Alpha beta plus beta gamma plus gamma alpha is equal to coefficient of x upon coefficient of x cube, that is c upon a, and alpha into beta into gamma is equal to minus constant term upon coefficient of x cube, that is minus d upon a. In this concept, we will discuss about the division algorithm for polynomials. Division algorithm states that for any two polynomials fx and gx, where gx not equal to 0, then we can find the polynomials qx and rx such that fx is equal to qx into gx plus rx, where rx is equal to 0 or degree of rx is less than degree of gx. Also, if rx is equal to 0, then gx divides px, and if rx is not equal to 0, then gx is not a factor of px. This result is known as division algorithm for polynomials. Now we will understand this concept with the help of an example. In this example, we want to check whether gx is a factor of px or not. Here, first term of quotient is x to power 4 upon x square, that is x square. And the second term of the quotient is minus 2x cube upon x square, that is minus 2x. We find that the remainder is minus 2x plus 1. Thus, gx is not a factor of px.